Maths for second PUC students. I have the question here for 2 sine inverse x is equal to sine inverse 2x minus 1 minus x square. I have to prove. The question is from inverse trigonometric function. Let me consider x is equal to sine theta. So if I use the inverse trigonometric, theta will be sine inverse x. So I'm doing this substitution in the RHS. The RHS is sine inverse 2x root 1 minus x square. So if I replace x with sine theta, that will become sine inverse of 2 sine theta root of 1 minus sine square theta. As we all know that 1 minus sine square theta is cos square theta. So sine inverse 2 sine theta under the root cos square theta, and that will be sine inverse 2 sine theta multiplied with cos theta after coming out from the root. So we can continue here using the trigonometric formula. We have 2 sine theta cos theta is equal to sine 2 theta. Therefore, if I substitute that, I get sine inverse as sine 2 theta. Now I can cancel the sine inverse and sine of the inverse trigonometric function, and this function becomes 2 theta. And 2 theta, if I resubstitute theta as sine inverse x, I'm getting 2 sine inverse x, which is RHS. So LHS equal to RHS. Sorry, this part is LHS. I got the LHS. Hence, LHS equal to RHS. We proved. Let me take my second question. From the chapter determinants, I just have to show that determinant of A and determinant A dash are equal, where A dash is the transpose. So as we have A is equal to 1632, its transpose A dash will be 1362. So how to find the determinant of A? Determinant of A is determinant of A is 1632. That goes 1 2s are 2, and the left top corner to the left bottom corner, that is 6 3s are 18. So 2 minus 18, I get 16 here, negative. And let me do the determinant of A transpose. There it is 1 into 2, that will be 2 minus 6 3s are 18. 2 minus 18, I'm getting negative 16. So determinant of A and determinant of A dash, they are equal, hence proved. Let me take the next question. have this question from vectors. So the four coordinates of a vector is given. So we have to find the area of this parallelogram. For that, we have to find the vector. These all four are the vectors OA 5 comma minus 1 1, and OB is minus 1 minus 3 4, OC is 1 minus 6 10, and OD is 7 minus 4 and 7. So we are finding the vectors AB, AC and AD. So AB and AC will become the adjacent side of a parallelogram. If I consider a rough parallelogram, A, B, C, D. So if I want to find the vectors AB and AD, so area of the parallelogram is cross product of the vector AB into AD. That's the adjacent two sides. The magnitude of the cross product of the two adjacent sides of a parallelogram. So vector AB is obtained by OB minus OA. In that sense, OB minus OA will be minus 1 minus 5 comma negative 3. I'm taking the coordinates between these two. Negative 3, negative of negative 1 will make it positive. Similarly, the z coordinates 4 minus 1, which is minus 6 minus 2 and 3. Similarly, if I want to find AD, that will be OD minus OA. That's by the triangular law of vectors. OD, that will be the coordinates of D with A, 7 minus 5 comma minus 4 minus of minus 1 and 7 minus 1. So this vector ends up to 2 negative 3 6. After that, we are finding the area of parallelogram ABCD, which is the magnitude of cross product of AB cross AD. So that can be solved by the determinant. The first row, I have to consider the ijk coefficients. I, j, k. It's I, j, k. Second row will be the coefficients of AB, vector AB, that is 6, minus 2 and 3. And the third row will be the coefficients of side AD, that's going to be 2, minus 3 and 6. So finding the determinant of this, it's going to be the modulus of I multiplied with minus 2 into minus 6 minus 12. Minus of minus will become plus, 3 3s are 9. Second coefficient, we have to make it negative, so j multiplied with, eliminating the row and the column where the j belongs, so multiplication of 6 with minus 6, that's minus 36, and these two corners, 3 2s are 6. The third coefficient, that is k multiplied with, eliminating the first row and the last column, minus 6 into minus 3, that's 18, positive 18. Minus of minus 2 into 2, that will become plus 4. Hence we find, so all of these are magnitude because area is a scalar number. So I multiplied with, it goes minus 3i. So minus 3i, minus 36 and minus 6, minus 42. Minus 42 multiplied with minus j will become positive 42j, and 18 plus 4, 22, 22k. So the magnitude of this will be the under root, the square of the coefficient, that's 3 square, which is plus 42 square plus 22 square, where I get under the root 9 plus, I can find out 42 square as 42 times 42, 1764, and 22 square is 484. And the sum of these three, 2257, and the root of that value is 47.50 square units. If you find useful on this video, please like and share. Thank you for watching the video.